Now, last lesson we were doing centre of motion is not zero. We started with the displacement function. We then worked out the velocity function, and then we worked out the function for acceleration. And then if you're ever asked to show that this is simple harmonic motion, you need to show that the acceleration is proportional to the displacement. So here is your equation for displacement. So if I take this b over the other side, x minus b equals a cos nt plus alpha. We've done this last lesson. So the a cos nt plus alpha here can be replaced with x minus b. But I'm going to write this as negative n squared times a cos nt plus alpha. And now what I'm going to do here, I'm going to replace a cos nt plus alpha with x minus b. Okay? So therefore, when the centre of motion is not zero, we have shown that the acceleration is proportional to the displacement minus that centre of motion position. Okay? So therefore, it's simple harmonic motion. Because it's of the form, acceleration is negative n squared. I'll just put x minus c, where c is the shift. Where c is where c equals centre of motion.
Is c the same as b?
Yeah, I can put b. It doesn't matter. Okay? I'll put b, where b is the centre of motion. Okay? So we are showing that, therefore, acceleration is proportional. So acceleration is proportional to
Miss, can you just drag with this?
yeah. So therefore the acceleration is proportional to x minus b. Displacement minus where the centre of motion is. If it's normal simple harmonic motion and there's no shift, it's just acceleration is proportional to, is equal to negative n squared x. But when there's the centre of motion is not zero, in other words, it's shifted up or down. Okay, when it's shifted up or down, then the acceleration, so that's the normal curve, but if it's shifted up or down, it'll be acceleration is proportional to negative n squared x minus b, where b is the centre of that motion. So b might be up here, the centre of motion there. Now, I haven't done a sideways shift on this, okay, with the alpha yet. I need to talk about the shift of the alpha as well. So is that where we got to last lesson? We just got to that? Okay, now, there is a few things. There's a few things that we need to define. If we just look at that curve up there, let's just look at the following, what the period is. Now, we know a lot of this, okay? So what have we got? Oopsie, we can't see it. So I'll just write out the function again. X equals a cos nt plus alpha plus b. So what's the period? Oh, you had all this from last lesson. What's the period equal to? 2 pi on? Yeah. Okay. The amplitude, just going through these again.
Is it A?
Yeah. Amplitude is maximum displacement from wherever it's going to be A. Yep. Now, these are some new things. Frequency, we haven't done. So the frequency equals, so this is new. So you can write down your period, you can write down your amplitude. Period is the time taken for one oscillation. Time taken for one oscillation. The amplitude is the maximum displacement, this time from, maximum displacement from where? The origin or from somewhere else for this one? From the centre of motion, in this case it's B. Yep. The frequency equals the 1 on T, 1 on the period, so 1 over the period, we'll just call it 1 over the period. So it's the reciprocal of the period. That's the frequency, which is, if you ever asked, n on 2 pi. And the frequency is the number of oscillations per second. So that's new. And there's a few others that we need to know. So you know period, you know amplitude. Frequency is the reciprocal of the period, so it's 1 over the period, which is n on 2 pi. It's the number of oscillations per second. The phase is this bit in here, the nt plus alpha. That's what it's defined as. That bit's called the phase. And the initial phase is just the alpha bit. So in some questions in Cambridge, you're going to be asked for the phase and the initial phase. You might be asked for the period as well. Okay? Now, when you are doing simple harmonic motion, we often use, so for simple harmonic motion, x equals a cos nt plus alpha plus b can be used, or x equals a sine nt plus alpha plus b can be used as well. Now, it's just that if you're using the sine one, it's just starting at a different point, that's all. You're just 90 degrees down the road. The difference between cos and sine curve is 90 degrees because, you know, they're complementary. All right? So, but we do tend to use the a cos nt plus alpha one, okay? But they both can be used. Now, which one would you choose? The reason they can both be used is since cos theta is sine 90 minus theta, which is, one sec. There are two things you could be asked, apart from, look, you'll be asked to substitute values of x and find the b and the t and all that sort of stuff. You'll be okay with that. But sometimes if you've got x, then you'll find v and then you'll find a, and you can be asked to do two things. To show that a equals negative n squared x or negative n squared x minus b, where there is a shift in the centre of motion. You can be asked that. The other thing that you can be asked, so that's one thing that you can be asked. The other one is the v squared equals n squared, a squared minus x squared is the other thing that you can be asked. And we can also go backwards from there. So, when you've got your equations, so a few things that they can ask you are, you've got a equals cos nt plus alpha plus b. We worked out before that the velocity was negative an sine nt plus alpha. We also worked out that acceleration was negative an squared cos nt plus alpha. Yeah. So we've worked those out. There are a few things. So the results that you can be asked to prove are a squared, a equals negative n squared x minus b. The other thing that you can be asked to do is to show that v squared equals n squared, a squared minus x squared. So we're going to do that now. We did it before with the normal equation. We're now going to do it with the shifted curve. So we know that x is that, velocity is that, and acceleration is that. I want you to show that v squared equals n squared, a squared minus x squared. So you would start with v squared is what? Well, that's v. What's v squared? Just square it. We did this before, remember? So negative, well, it's squaring that whole thing. So it's negative an squared, and it'll be sine squared nt plus alpha. We okay with that? I'm just squaring that. That's velocity. I'm squaring it. What do you get? A squared, n squared, sine squared, nt plus alpha. That's what v squared is. Now, do you remember what we did before when we did this? Girls, we're trying to show that v squared is n squared. We can see an n squared, but we need a squared minus x squared. Just for a hint, A is in terms of cos, and so is x. So you're going to change your sine squared into 1 minus cos squared. You know how sine squared x plus cos squared x equals 1? So if you have to show this result, a squared, a is in terms of cos, and so is x. So therefore, that's an a. So therefore, you want to change this sine squared form and write it as 1 minus cos squared nt plus alpha. Now what do you think you can do? Well, so it's a squared n squared 1 minus, guys, what's cos nt plus alpha?
What's your question?
Oh, do that. Show that v squared equals n squared a squared minus x squared. All right, let's see if we can come up with an expression for that. Oh, I know what our little thing at something. You won't be asked to do this for the shifted one, so you'll only be asked to do it where the centre of motion is the origin. So if you're asked that, you won't be asked it this way. The derivative's still the same, so's that. Remember we did this before? So you'll be asked it where the centre of motion is the origin. So when you rearrange the x equation, do you remember we did this? What do you get? X on A. So that's x on A. So now you can substitute your cos squared nt plus alpha. What do you get? So you get, remember we did this? We did do this before. We've done it. But you need to look at it again. So now expanding, you get a squared n squared minus n squared x squared. Taking out n squared as a common factor, a squared minus x squared. So you'll be asked that. You can be asked that. Sorry about the plus. A squared equals negative n squared x or negative n squared x minus b. For the normal graph that's not shifted up or down, you can be asked to show v squared is n squared a squared minus x squared, but there is one more thing that you can be asked. So you can also find v as a function of x. I know. From acceleration. I know it's repetitive. So you can also find v as a function of x from acceleration. So you know how we know that acceleration equals negative n squared x? You can find the velocity. So if you're given that, remember that if that occurs, if a equals negative n squared x, then it means we've got simple harmonic motion. So if you're ever given that, we can derive this equation up here, v squared equals n squared a squared minus x squared. What do you think we do? V is what? Actually, no. No, we can't do it. You can't. We're not going to do that. Do you remember the result? d by dx, what does acceleration of a half v squared equals, acceleration, wasn't it?
Yeah.
Equals d squared x by dt squared, which is acceleration. Do you remember this rule? We did this last week where we looked at the result. Do you remember if you've got acceleration as a function of x and you want to find velocity, this is what we do. We rewrite the acceleration as d by dx over half v squared, and so what do we go? That is d by dx of a half v squared. Now we did this about a week ago or a bit more, but we've never done it with simple harmonic motion. But it can, because this is a in terms of x, you can do it for simple harmonic motion as well. So d by dx of a half v squared is negative n squared x. So doesn't that mean if you differentiate this, you get that? So if you integrate that, you get this. Okay, so therefore a half v squared equals the integral of negative n squared x dx, which is a half v squared equals, so we just need to remember these things. So these are the things that you can be asked, apart from the straight substitutions. Now I know you'll be fine when we do the straight substitutions, but it's these other things, the v squared result, doing this result as well, that tends to get kids caught. So what do we get there? Negative n squared x squared on 2 plus c. Now, All right. What do we know? This is simple harmonic motion. I haven't given you any information, but you can tell me at the endpoints, what do you know about times? We're going to have to find a relationship between x and v. Tell me when v is 0. V is 0 when? Here's my simple harmonic motion. No. That's the centre. That's x equals a at the endpoints. So here velocity is 0 up here, do you remember? And there. And that's the fastest. So it would be really good to substitute when x is a, v is 0. So at the endpoints, end of a pendulum, kid on a swing, provided no air resistance and whatever, at when x equals a, v equals 0. So remember, we need to make the substitution for x and v to find c. So when x equals a, v is 0, so we get 0 equals negative n squared a squared on 2 plus c, which means that c equals n squared a squared on 2. Are we okay? So therefore, a half v squared equals negative n squared x squared on 2 plus n squared a squared on 2. What are you going to do now? Multiply through by 2. Multiply through by 2. What do you get? We're done. So if you multiply through by 2, you get v squared, because a half of 2 is 2, equals negative n squared x squared plus n squared a squared. Multiply through by 2. And what can we do now? You're done. What do you get? N squared a squared minus x squared. Okay? So you have to know how to do all those things. Start from the a equals negative n squared x and derive that result. You have to know how to derive the v squared equals n squared a squared minus x squared from the original cos equation, and you have to know how to derive a equals negative n squared x minus b, or a equals negative n squared x. All right? I think that's it for what you can be. To do 3 examples. The first example is just the straight equation with no initial phase, no sideways shift. The second example will have a sideways shift. There'll be a plus alpha there. And the third example will have an initial phase, a sideways shift, and a centre of motion shift. So we're doing 3 types. These are all just very, just substitution and working stuff out. If you're good with your trigonometry and solving equations, you'll be fine with these. But there is always, you should always be graphing them and interpreting your solutions in context with the graph.
3 cos 2 pi t.
That's right, 3 cos 2 pi t. So the displacement of a particle is given by the equation x equals 3 cos 2 pi t, where x is in centimetres and t is in seconds. First question, show that the motion is simple harmonic. Do you know what to do? What do you have to prove? That is negative n squared x. Okay, good. So we start with x equals 3 cos 2 pi t. What do we do next? Parts A and B and C. I'm just going to pause the video and you can work out the velocity, the acceleration, show it's in the form negative n squared x. Then you can find the period, amplitude, frequency, phase, initial phase, and I want you to find the initial and velocity and acceleration. What have we got for velocity? Isn't it 3 times negative sine 2 pi t times 2 pi, which is negative 6 pi sine 2 pi t, and acceleration is negative 6 pi times cos 2 pi t times 2 pi, which is negative 12 pi squared cos 2 pi t. Now you have to show that it's in the form of negative n squared x. Now, what does x equal? 3 cos 2 pi t. So that is the same as negative. I want 3 cos 2 pi t here. So I need to put negative 4 pi squared. Negative 4 pi squared times that. Now, the negative 4 pi squared can be written as 2 pi all squared, can't it? See, it's got to be n squared x. Put the 3 here, because that's x. And this needs to be negative, and this needs to be in the form of n squared. Now, 4 pi squared is 2 pi all squared, so which equals negative 2 pi all squared x, which is in the form, which equals negative, so acceleration therefore is equal to negative n squared x, where n is equal to 2 pi. So therefore, can you put a little sentence, therefore, to prove, so therefore, acceleration is negative n squared x. Are we okay? So therefore, acceleration is proportional to the displacement, but it has to be n squared x as well, where n equals 2 pi. So from there, we've gone negative 4 pi squared times that. Okay, can we continue? The period. Period, go back to the original curve. It's 2 pi on n, which is 2 pi over 2 pi, which is, because the n is 2 pi. So it's 1 watt. Give me units. Second. Okay, 1 second. The amplitude is, we're looking at 3 cos 2 pi t. No, amplitude's only from the middle up or from the middle down. So it's not 6, it's 3. I will draw this in a minute, all right? The frequency, do you remember what that was? 1 over the period, which is 1 over 1, which is 1. Units. Oscillations per second, 1 oscillation per second.
Oscillations to the negative 1.
That makes sense. All right, the phase, you know how it's nt plus alpha? Sorry, this is a bit small, isn't it? The phase, we've got no phase, it's 0. Sorry, no. Sorry, it is 2 pi t, good. But the initial phase is 0. Because there's no plus alpha. So the phase is 2 pi t, the initial phase is 0. Sorry, I should have spaced this out a bit more. Now, initial velocity and acceleration, we've got the velocity equation. So, yep, sub t is 0 for initial velocity. So you get negative 6 pi sine of 0, which is just 0 meters per second. So initially the particle's not moving, and the initial acceleration, just putting that into the acceleration equation, there's a nice acceleration one, that one. So it's negative 12 pi squared cos 0. What's cos 0? 1. So it's negative 12 pi squared meters per second, because cos of 0 is 1. Now, I've got to draw some graphs soon. Okay, we're going to do, so next bit, determine the greatest displacement, velocity and acceleration. So we want the greatest displacement. We better put the equations up, otherwise we can't do this. So I'm going to write the equations. X equals 3 cos 2 pi t. V equals negative 6 pi sine 2 pi t. And acceleration is negative 12 pi squared cos 2 pi t. So this is the easiest one of all the types. We'll start with an easy one. So we want the greatest displacement, velocity and acceleration. Go. Greatest displacement is what? Anyone? Do you want me to draw them? We can draw them. All right. Greatest displacement is, what does this look like? Like that. That's the displacement curve, x. The period is, what was the period? 1. Okay. Greatest displacement is 3 metres. When? Now they're saying displacement, so we're going to go specifically with direction and magnitude. Greatest distance from centre of motion would be 3 and negative, like 3 metres to the right, 3 to the left. We're going for displacement in the proper sense of the word. 3 plus 3 is greater than minus 3. Okay? So the greatest displacement is 3 metres when t equals, I suppose, 0 and 1 second on this particular graph. Okay?
0.5, but in the note.
All right. If we want to put that is a greatest displacement, that would be, all right. Now, what it is 3 metres because it's positive 3. This is the greatest distance to the left-hand side of the origin when it's half a second. Okay? So we're just going to keep it as the plus 3 is greater than the minus 3. Okay? Greatest velocity. So when is velocity the greatest? We can draw the velocity curve because I think I did it both ways earlier, didn't I? I put the plus and minus. It looks like, yes, it is. It is. What a disaster. Oh, wait, why don't we make that the acceleration one? That works for acceleration, doesn't it? That's acceleration, negative 12 pi squared. 12 pi squared, that's the acceleration one. I'll draw the velocity one down here. Velocity is the negative sign one like that. Okay? Velocity. Good. What do we got? 6 pi minus 6 pi. Huh? 1. Okay, 1. So there's the velocity curve down the bottom. Greatest velocity is when? If that's 1, that's a half. That's, what do you think that one is at? Time what? Yeah, so greatest velocity. Look, if you don't want to draw this, the other thing is greatest velocity is also when x is 0, but you'd have 2 points here. And the other thing is, but tell me about the gradient here. Positive or negative? You know how greatest velocity, velocity's got magnitude and direction. Continue next lesson.